Hey guys, Mr. Harbinger's here, and we are going to go over review A for the quarter 4 exam. So I'm going to get moving on this. Find the inverse of. So really what I'm going to do is I'm going to rewrite this first. I'm going to say rewrite, and I'm going to put it as a y equals instead of an f of x because I think people are more comfortable with y equals. And now I'm going to do the inverse. So when I do the inverse, I'm going to label it here too, just so people don't get mixed up. The inverse is where you switch x and y, and then you do whatever it takes to get y by itself. So I'm going to add 11 to both sides. And then I'm going to divide both sides by 5. And whatever I have left is the inverse. And right now I've got an 11 plus x all over 5, option number 4. So we're looking at that one, and that would be the inverse. Number 2. So you've got some nice tricks here if you wanted. You could pick your favorite number that's bigger than 2 and kind of prime. So I picked something like 19. You could plug it in for x here and here, and you get a horrible decimal. And then you could plug that same number in for each one of these guys, and one of them is going to have the same exact decimal match. I'm going to do this one algebraically, but you can go decimal matching if it makes you more comfortable. So x to the 3 halves and x to the 4 thirds. It's okay to rewrite the radical like a fractional power. Now you might remember that when you are multiplying like bases, you can add the exponents. So I'm talking about x to the 3 halves plus 4 thirds. That's all because if you took something like x squared and you multiplied it by x cubed, we're talking about x to the 5th. All right, 1, 2, and this one's 1, 2, 3. And how many do I have? I have 5. So now I've got to add those two fractions. So I'm going to switch colors just so people don't get mixed up. But I'm going to bring it this way. I know my common denominator is 6. So let's see. I multiplied the 2 by 3, so I'll multiply the 3 by 3. I multiplied the 3 by 2, so 4 by 2. I'm talking about x to the 17 over 6. Which is right there, option 2. Okay, what interval is the graph increasing? So where is the graph going up? As I go from left to right. So as I move from left to right, I'm going to choose highlighter here. Okay, so I'm going to choose highlighter. Oh, that one right there. Duh. So I'm dropping down on the very left-hand side, but on this interval, it's going up. And that's the only interval during which it's going up. So you care about x values. So my x values are, let's see, I've got this right here, all the way over to this. So it looks like there's a little hash mark here as well. So -2, all the way over to 0. That's where it's increasing. There's a period of decrease on the left and a period of decrease on the right. But as I move up from x equals -2 to x equals 0, that graph is getting taller. So it's got to be option 4. All right. Question 4. Given those functions, can you subtract them? So you could probably do this in the Inspire. Just be careful about which function is subtracting which. But if they're telling me find g of x minus f of x, so g of x is 2x squared plus 8, and f of x is 5 plus 2x. And I want to subtract. Well, I have a hard time subtracting. I'd much rather add negatives. So what I'm going to do is I'm going to take a negative side, and I'm going to make this a plus, and I'm going to change the signs of everything inside. So now I can go and collect my like terms. So let's see, I've got 2x squared is the only x squared term. There's no other x squared terms. I'm talking about this guy right here. In terms of x terms, I only have that -2x. And I have a 8 plus -5 would give me a 3. So 2x squared minus 2x plus 3 is option 1. Right, what's the period? So you might remember there's two formulas that kind of go hand in hand. So period is 2 pi over the frequency, which some teachers call beat. And you might remember that frequency is 2 pi over the period. Now, here I've got to pick which one I think is more appropriate, but seeing as how they give me the actual equation, whatever's inside the parentheses in front of the x, that's my frequency. So my frequency is 4 pi. So this right here it's hard to read because it's in yellow, but that's my frequency. So I'm going to plug it into the blue equation. Period equals 2 pi over whatever the frequency is. The frequency is 4 pi. So I'm just going to reduce my fraction, and I get a 1/2. Because the 2 and the 4 drop down to 1/2, and the pi's cancel. All right, the quotient. There are a couple ways to get this right. So quotient, we're talking about long division. And I might do this one a few different ways, but there's 3 ways, and 2 of them are fast. Ideally, you could sub in a -2 because it's x plus 2. You could say, hey, a -2 would have made that 0, and you plug in a -2 for each of these guys, and whatever you get out of it, I guess would tell you if, scrap that. Would tell you if it's a factor or not, but really that's not what we're looking for. So let me backtrack. There are 2 ways. I'm going to do the faster way, and then I'll do the longer way. And if you don't like what I'm saying, then you could just fast forward the video or something like that. A quotient means, hey, that x plus 2 times something gives me x cubed plus 7x squared plus 2x minus 16. So I've got this multiplication thing going on right here. And I bet you know that x times something would give me x cubed. And everybody's like, oh, it's x squared. But of course it is, right? All of the options involve x squared. I'm focusing instead on the right-hand side. I've got a plus 2 times something equals -16. Well, the only thing that 2 multiplies by to give me -16 is -8. And this one is the only one with a -8 as the constant term. That's why I know it's option 2. But it's not the kind of thing that people normally think about during an exam. There's kind of a canonical approach, I guess. So I'm going to do the long division, and I might make it messy, and I'm sorry in advance if I do. Okay, so I really worry about multiplying this x right there into the polynomial on the right. So I say x into x cubed, and I know that's x squared. So I'm going to write my x squared up top. And now I'm going to multiply that x squared by x and by 2. So x squared times x is x cubed. X squared times 2 is 2x squared. And you already know what I'm about to say, because we've done this 1,000 times. I'm going to subtract like I would normally subtract during long division. Oh, wait, I don't like subtracting. I really like adding the opposite. So I've got some negative signs instead. And now I've got, let's see, x cubed minus x cubed is 0. 7x squared plus -2x squared is 5x squared. And I'm going to bring down that 2x. All right, so far so good. Now I've got to take that x that we were talking about before, and it's going to divide into 5x squared. So x into 5x squared is 5x. Right now you can actually stop because option 2 is the only one with plus 5x. But just to make this more complete, because people probably worried about what if there's a long division problem on the final, I'm going to keep going all the way to the end. That purple 5x times x is 5x squared, and 5x times 2 is 10x, and I'm going to subtract. Oh wait, I really like to add the opposite instead. So, let's see. Forgot that. 5x squared minus 5x squared is 0. 2x plus -10x is -8x. And now I'm going to bring down that -16. And again, I'm going to take that x that's out front and divide it into the polynomial on the bottom. So x goes into -8x, -8 times, right? X times -8 is -8x. So I'm going to take that red -8 on top and multiply it by the binomial on the left. So -8 times x is -8x, and -8 times 2 is -16, and you might see where this is going already. I really, really, really don't like subtracting stuff. Instead, I prefer to add. And if I add it all, I just get 0. So that's why option 2 is the quotient. Hey, I did all this division. It's pretty, a lot of colors. And it ends up on that. Okay, which binomial is not a factor? Look, you could factor it all, and it's kind of nasty. What I choose to do is graph it. So x cubed minus 4x squared minus 7x plus 10. All right, not what I'm looking for. Chrome is being a pain. You know what? Desmos.com/calculator. There we go. So we said x cubed minus 4x squared. Checking. All right. So I've got roots, I've got zeros, I've got solutions at these 3 spots. I've got roots at -2, 1, and 5, which means I have factors at x plus 2, x minus 1, and x minus 5. Remember, the relationship between factors and roots is they have opposite signs, but the numbers match. So x plus 2, x minus 1, x minus 5. You know what? I can do better. I'm going to snip tool just so when I bring it over, I can remember. Because if you didn't figure it out already, my memory is awful. Come on. Holy smokes, it is not. Oh, good. Computer froze. Sorry, guys. So I'm going to delete the component if I can. Come on, graph. Sorry about that. It crashed my entire computer. So I had to restart everything. And I'm picking up where I left off. So we talked about x plus 2 and x minus 1 and x minus 5. That x plus 4 has nothing to do with this. So that one is number 3. Okay, find f of x times g of x given those 2 functions. We can do that. Let's see, f of x is 2x plus 6. And we've got g of x, which is x minus 3. And we are going to double distribute. I've got that 2x in blue. That times x should give me 2x squared. And then I've got 2x in green times that -3 should give me minus 6x. Then I've got to worry about the 6 right there. And it's going to multiply by that x and by that -3. So that's going to give me plus 6x. And then 6 times -3 is -18. So all I have to do now is clean up my like terms, and I should be okay. It looks like this -6x and this plus 6x are going to wipe each other out. Leaves me with 2x squared minus 18. That's kind of nice. All right. Ball is thrown off the edge of a bleacher. Oh my gosh. Distance in meters the ball travels, blah. Average rate of change between 1 and 3. So what we're going to do is we're going to plug 1 in to that equation that they give us. Then we're going to plug 3 into that equation, and then we're going to do the slope formula. So I'm going to find d of 1. If I can write better, be nicer. There we go. So -0.6 times 1 squared plus 20. Let's see, -0.6 is what, like 19.4 or something. All right, next I'm going to find d of 3, which is -0.6 times 3 squared plus 20. Let's see, 3 squared is 9. 9 times -5.4, 14.6. Give me 1 second. Sorry, I'm a dad. Dad duty called. Had to pause for a second. So we've got our 2 outputs. Now I'm going to do the slope formula for inputs, which means I'm going to do 14.6 minus 19.4, all divided by 3 minus 1. So you might remember the slope formula from Algebra 1 or something like that, but I'm looking at negative 4.8 all divided by 2, which is negative 2.4. So not bad. All right, cos of C using the right triangle shown. So the problem with cosine of C is when I go to label my triangle, I've got hypotenuse kind of there. You know what? I could just type it in. I've got hypotenuse right there, and I've got opposite over here because I'm really caring about angle C, right? If they're talking about cosine of C, I care about the angle C that's over here. Cosine of C is adjacent over hypotenuse, so I need side BC. So in order to go find that side, I have to go calculate it first. So let's see, 10 squared plus, I don't know, I'm going to do BC squared. And if you don't like that, if you prefer like putting an X there or something like that, that's fine. Let's see, and that's 25 squared. So do my squareds, and I'm going to subtract 100 from both sides. So when I subtract 100 from both sides, I still have this BC squared is 525. And in order to get rid of the squared, I'm just going to square root both sides. So I've got this radical going on to wipe out the square. And I'm checking in with BC at radical 525. Oof, 22.9. I only know that because I'm looking at the choices, and there's nothing else it could be. So right now I've got 22.9 right there. Now when I talk about what's the cosine of C, it's adjacent, which is that side, over hypotenuse. So 22.9 over 25. That. All right. Just a heads up, it's going to do announcements in a minute, and it's going to be like a bell, so I'm just letting you know when you start hearing that stuff. I don't really feel like pausing it over and over and over, so roll with it. Hey, the New York State Fair, ride goers, Ferris wheel, platform, 8 feet. Hey, which graph is that? You could absolutely graph every single option here. One of them is going to be right. Right? You could change your window to look like this. So X goes from 0 all the way over to 20. And your Y-axis can go from 0 all the way up to like 230 or something like that. One of them is going to look like this. But instead, I'm going to treat it like I have no clue. So my first thought is it starts off really low, and it comes up higher, and then it dips down low again. When it starts at a minimum and comes up, we're talking about a negative cosine. So I know that somewhere in there there's a negative cos, which means it has to be option 2 or option 4. So I'm going to cross off this and that just to make my life easier. If you can cross off half of your choices based on the shape alone, that's great. Like you can really improve your odds. So what's next? I could find the midline because the midline would automatically answer the question. Right? I don't really have to worry about period and frequency because they all of the options have the exact same frequency. So I'm not super concerned, but it looks like my height of 220 and a height of 8. So if I average them, I'm going to get the midline, which means 220 plus 8 all over 2. 228 over 2 is 114. So over here on the side somewhere, I've got a plus 114, and that's automatically option 4. I don't have to go find the amplitude. I don't have to find the period, which would be 6, right? 3 to 9. And then do the 2 pi divided by whatever. Okay. There is a fun algebraic way to do this, but it's multiple choice. So I'm going to graph the left-hand side, and I'm going to graph the right-hand side. So left-hand side when graphed is that, and the right-hand side is this. And I'm going to make life easy on myself. X squared, let's see. X squared plus 3x minus 10. X squared plus 3x minus 10, I think. All right. And then x over x plus 5. Great. And then this other one is 4 over x minus 2. So I think it's a lot easier when you graph them because now I'm just looking for points of intersection. So there's one right here, and there's one right here. Right? I don't even have to zoom. I don't even have to zoom out or anything. I can just find their intersections on Desmos. You could do the same thing using an Inspire. You could graph it and then analyze graph, intersect, or something like that. But my answers are -2 and 5. If we did this one algebraically, I'd be going for the next 10 minutes. Right? We're finding a common denominator. We're multiplying through. We're canceling stuff. Not very fun. So anyway, I've got this one, Brianna, $87,000. They don't give you the formula, but it's not the worst one in the world. It's the one you use for Algebra 1. So Brianna, $87,000. It's going to be, let's see, A equals P 1 plus R to the T, one of those. So we can plug stuff into that. Let's see. I don't know what the salary is after a while, but I do know that she started off at $87,000. It's 3%, and be careful. You need to use 0.03, and then it says 5 years. So we're just going to plug that into a calculator, and whatever we get out is the answer. So 87,000, 1 plus 0.03 to the 5, 100,856. Option 3. Right, that's a nice one. The zeros are. Okay, so I'm going to graph this also. What we could be doing right now is doing like factor by grouping or something like that. I'm just going to graph it. X to the 4th, 5x cubed. Try that right? Yeah. So I'm just going to look for the zeros. Hey, there's one there at -5. There's one there at -2, 0, and +2. So -5, -2, 0, and 2. -5, -2. Option 2. Option 2. Because that's 0. Man, what is up with this pen? I think it's the smartboard. Then it's +2 and -2 and -5. So done. Option 2. Okay, we're more than halfway done. Simplify that where it's the imaginary unit. So people forget that I squared is -1. I'm going to take that 2 and I'm going to distribute it momentarily. So that 2 right there is going to be inside. And I'm going to simplify. I'm just going to shift it to the right because the smartboard's getting weird. So that's x squared, I squared. You can always distribute the exponent. Plus, and there's my x I cubed. So I'm going to remember what I squared is. If you don't know what I squared is or I cubed is, you can put it in a graphic calculator. If you really need some notes, you can remember that I to the 0 is 1 because anything except for 0 raised to the 0 power is 1. Also, anything to the first power is itself. I squared, by definition, is -1. And I cubed is the odd one out. It's -I. And if you say, wait, what about a higher power like 5 or 7 or 30,000 or something? It's cyclical. It goes in a pattern. So if you ever wanted to find out what I to the 4th is, it jumps up to the very top again. If you ever want to find out what I to the, 11th is, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's I cubed, which is -I. So that's kind of cool. I'm going to plug my red powers of I into my blue formula. And we'll see what we get. X squared is just x squared. I squared is -1. X is x, and I cubed is -I. Okay, that's -x squared, and that's -ix, which looks awful, but that's it. There is no simpler version. All right, when you see factor completely means there's probably 2 steps in the factoring. So you might want to look for a GCF. If there's no GCF, maybe factor by grouping. In fact, since I can't GCF, right, there is no greatest common factor that all of them share. I'm going to try to factor by grouping that half, and then I'm going to try factor by grouping by this half. So what's my greatest common factor with the green terms? That's x squared. What does x cubed and 3x squared have in common? They have an x squared. Leaves me with an x when I take an x out, and a 3. If you redistribute, you get x cubed plus 3x squared. All right, I also am going to take that -9 out from the yellow stuff, but instead of using yellow, I'm going to try just like a darker color. Maybe that helps. Maybe not. Try gold, whatever it is. I guess it's going to work. It's like mustard or something like that. I'm going to take a -9 out. They both share a -9. And when I take a -9 out of -9x, it leaves me with an x. And when I take a -9 out of -27, it leaves me with a 3. The fact that my two terms in parentheses, x plus 3 and x plus 3, match means I know I did it right. Okay, batter up. I'm going to write down what they have in common. And I'm going to write down what they don't. And then I'm going to break down anything I can. Now, x squared minus 9 is a dots problem, right? It's a difference of two squares, which means x and x, 3 and 3, one gets a plus and one gets a minus. That's factored completely. It is broken down and it cannot be broken down anymore. I don't even have to solve. It just says factor. The graph shown to the right has got a leading coefficient of 2. Write a possible equation. Don't mind if I do. So really what we care about here is the factors. I'm not really going to sweat the y-intercept too much. Something we would normally focus on. I care about that point. I care about that point. I care about that point. 1, 2, 3, 4, 5, and that's a 1. So I'm going to write it in factored form. Remember, we switch signs and we talk about factors versus roots. Of course, I say that and I completely wrote the wrong symbols. So there we go. And it says leading coefficient of 2. I'm not, last thing I could do is check, make sure that the right-hand side is trending positive, but it is. It's going up, so that's how I know my 2 is positive. There is no y-intercept I really have to care about right now. If I multiplied all this out, 15, -30, so that could, in theory, be like a -30 kind of thing. All right, exact roots. If you ever see the words exact roots, it means there's probably a radical involved, which means we're probably going to need the quadratic formula. So if you remember the quadratic formula, awesome. And if you don't, get good or get wrecked. So I just have to identify my coefficients and plug them in. So I already know it's not going to write on the left-hand side of the screen. So A is whatever's in front of the x squared term, which in this case is 1. B is whatever's in front of the x term, which for us is 14. And C is the constant term, which for us is 98. All right, here we go. -b, so -14 plus minus square root, big old ugly radical, b squared, which is 14 squared minus 4 times a times c, that's a 98, all over 2a. So I'm going to simplify it, but I'm going to change ink colors as I go so people don't get mixed up between, what's going with what. This doesn't change. I rewrite the radical and I leave it over 2. If you throw this in a TI Inspire right now, it's going to be really friendly to you. It should break it down just fine. Instead, I'm going to do it in stages because I don't know what 14 squared minus 4 times 98 is. But we could find out. So 14 squared minus 4 times 1 times 98, -196. All right. Which means right there. What I'm going to do now is I'm going to simplify that radical. If you can break down radical -196, awesome. It is a perfect square. So if you know it, great. And if you don't, that's cool too. Square root, I wonder if it does the negatives. It does not. So I'm going to do 196. And I'm going to remember that because it's a negative radicand, it's a negative under the radical, I can just add an I to this and say, hey, that's 14I. So it's just something we have to be conscientious of. I'm going to bust that over here. I've got -14 plus minus 14I all over 2. And the last thing I'm going to do, if I can, is simplify that radical. Simplify the fraction. It says simplest. And since negative 14 can be divided by 2, and since 14i can be divided by 2, it's exactly what I'm going to do. I'm going to say, hey, that's the same thing as negative 7 plus minus 7i. Right? They both get divided by 2. So that's my final answer down here in the magenta or whatever it is. Okay, this one's long division. So luckily we did one like this already. I'm going to do my best here to do it kind of quickly, but kind of in a tight configuration. So x cubed plus 9x squared plus 26x plus 24, all divided by x plus 4. All right, I'm going to do this one a little bit faster than last time. X, this guy right here, I'm going to divide it into x cubed. It gives me x squared. Uh-oh. X squared times 4 is 4x squared. But I'm going to add the negative versions, and I'm going to get 5x squared. So far, so good. And I'm going to bring down that 26x. All right, next up, I've got x right here up front, and it's going to go into 5x squared, 5x times, right? 5x in purple times x is 5x squared. That's how you know you got it right. 5x times 4 is 20x. And I'm going to subtract them. Not really. I'm going to go add the opposites. And I get 6x. It's kind of nice. All right, I still have to bring down that plus 24. So x goes into 6x. I'm going to use a different color. I'll use orange. This x right here goes into 6x. 6 times, if I get that better, this is 6. And 6 times x is 6x. And 6 times 4 is 24. And I've got to subtract them, and maybe you see it, maybe you don't. But I'm going to add the opposites. And I'm at 0. It wants me to write it in this form. State the quotient and the remainder in the form, which it's not enough just to leave it like this. It's probably tempting to be like, yeah, there's all my work. But at the same time, we can't just leave it. You actually have to tell the teacher what's what so they know that you know what you're talking about. So I'm going to say quotient is that number on the very top. And I'm going to say the remainder is what's left over. And they want to state the form. So we can do that. We can say, hey, the form is quotient plus the remainder over g of x. That looks ridiculous because that thing on the right, there's a 0 over something. Therefore, it's just 0. And we don't really need, it wouldn't say like, hey, 7 goes into 14, 2 remainder 0, right? Because it's just it's a factor, but this is how they want it, so they get it. Is this thing a factor of that thing? Yes. And it's a factor because we get a remainder of 0. That's it. Anything other than 0 would have been no. If we got remainder of 1, or remainder of -1, or remainder of, 3x plus 2 or something, not a factor. But if you get 0 as a remainder, we're good because it divided in nicely without anything left over. Couple questions left. Large city, current population of 500,000. It's decreasing. And how long does it take to hit half the original population? So I'm going to solve this one algebraically and graphically because I'm going to use that. I'm losing people. And I'm starting off at 500,000. And I'm losing 4.5% per year. So 0.045, be careful about the decimal, please. I don't know about my time frame, but if we're talking about half the population, it's talking about 250,000. Goes right there. So if I were to do this algebraically, I'm going to divide over the 500,000. A big error that people do is they multiply that 500,000 into that exponential base. That's not how you do it. That t up there is protecting it. You can't just multiply it in. Hey, when I divide that, I get 0.5. I get a half, which makes sense because, we're talking about half the population. That percentage, 1 minus 0.045, I'm good at multiplying stuff. I'm really bad at adding and subtracting. 955. All right. So we're looking at that, and you know how to solve an exponential. I don't want that exponent up top. Typically, if we have an exponent up top, you can put it in log form. So log, whatever the base is, whatever the other number is the argument, and the exponent is the variable. So I'm going to go compute the value of that log. Right, in order to bump from log down to base, I did an underscore. If you missed that one, the G in log, I did a shift hyphen, it's an underscore, and then I popped it back up for the 0.5, 1505. And it wants nearest tenth. So it said 15.05 is equal to t, which means I'm going to round it to 15.1. Hey, 15.1 years, we lost half the people. So what I'm going to do now is solve this graphically because I've got people that really prefer to solve it graphically. Okay, I've got y equals 500,000. Look, if you really want, you can do it like this. You could shorten it if you know how. You could graph it in terms of thousands, but whatever. There's 250,000. And you're thinking, wait, there's nothing on the screen. Of course not, because this is super crazy high up, which means I'm going to shift my window. My x-axis is 0 to, I don't know, 20. We already know the answer, so I can kind of cheat off that. You can make it bigger, like 100 or something, but my y-axis, my y-max is the tricky part, right? I've got to be bigger than 500,000. So I'm going to go 600,000, just so I know I see everything on the screen. And there's my point of intersection. The gray dot in Desmos tells you where something interesting is happening, and it's happening at 15.05. Hey, that sounds familiar. So the toughest part on the algebraic approach is probably what do you do with the equation at first? And you divide over the coefficient, and then you do log form. The hardest part on this is just getting the window correct. Anyway, 15.05, and then we're going to round it up to 15.1. Don't forget, if you do it graphically, you have to sketch the graph, and then you have to round it appropriately at the end. So what you could do, I don't want to snip the image again because it might crash the computer again, but you could screenshot it. If this was just like a worksheet or something, you can't screenshot on the final. But 2 questions left. Hey, you want to save for retirement? Yay! It's compounded monthly. The second you see compounded monthly, that's the one where you have to do the larger formula. Okay, when you're 30 years old, you put 4,500 and it grows and it grows and it's compounded monthly, and we're going to talk about 25. So I don't know how much money we have. I'm going to leave it like that. But I did put 4.5 grand in. The rate is 1.8%. So 0.018. If you do 1.8, you're going to get something ridiculous. So please be careful. It says compounded monthly. If it says compounded monthly, n is how many times a year does it happen? So there's 12 months in a year. And up top, we have n times t. So that's 12 times, t. How much time passed? Oh, from 30 to 65. 30 to 65 is 35 years. All I have to do now is just plug this into a calculator. Might as well just dual screen it while I'm at it. Tried to show off, then it didn't work. All right, so 4,500. 1 plus 0.018 divided by 12. And then upstairs we've got, and I'm going to use parentheses, that way it handles the exponent better. And you are at 844526. And what does it tell me to round to? Given blah, it doesn't say. So if it doesn't say and it's money, we round to the nearest penny. So 844526. It's done. And then the very last question, solve algebraically. LOL, no thanks. And we're done. Kidding. You won 100. So of course you're going to solve this one algebraically. People are dying, I bet, to solve this one graphically. You probably would put the left side into a graph. You'd put the right side into a different one. And we'd see where they cross. But it says solve algebraically. You have to solve it with algebra. If you just solve it graphically, you can get some partial credit, but you don't get all the credit. But it is a good check to see if you got it right. Right? That's like a nice function. So since I want to solve it graphically, I got to move that 2. And that leaves me with radical 2x plus 4 equals x minus 2. Now that I have a radical on one side, it means I can square both sides to get rid of the radical. So I'm going to square and square. Now, it gets a little funky for some people because they forget that a square takes out a radical, but they also forget that a binomial squared is that thing times itself. Be careful. It is not x squared plus 4 on the right. A lot of people say that, and a lot of people get it wrong. X squared minus 2x, because I'm doing the outside terms, then minus 2x again, because I'm doing the inside terms, and negative 2 times negative 2 is positive 4. I'm going to clean up that right-hand side, and then I'm going to start moving terms around. Okay, all in one shot, because I'm a show-off, I'm going to move both these terms over to the right. So subtract 2x from both sides. And I'm also going to subtract 4 from both sides. And that leaves me with 0 equals x squared minus 6x, and then nothing. Like the 4 and the negative 4 wipe each other out, that's cool. Still factoring though. Right, there's a GCF, which means I can write x equals 0 and x equals 6. So a lot of people are going to stop here and they're going to pick up like a 98 or a 99 in the test. Remember, after you solve a radical equation, you have to check for extraneous roots. So I'm going to plug a 0 into the very original equation, and if the left side equals the right side, we're good. Then I'm going to do the same exact thing with 6. So I'm going to say up here, check please, radical 2 times 0 plus 4 plus 2, is that equal to 0? Put a little question mark right there. Maybe. 2 times 0 is 0, plus 4 is 4, so radical 4 plus 2, is that equal to 0? Is 2 plus 2 0? So that's a no. 0 is not okay. So now we have to try 6. So same exact deal, but now we've got to see if 6 works. So I'm going to take orange, and I'm going to say check. I do this on the left, but you already know that the ink is not going to work out. So here it goes. I'm going to do radical 2 times 6 plus 4 plus 2. Is that equal to 6? Maybe. 2 times 6 is 12. 12 plus 4 is 16. Radical 16 plus 2. Is that equal to 6? Possibly. Radical 16 is 4. And 4 plus 2 is 6. So that checks. That's cool. Which means x equals 6 is the only solution. Reject. Done. Please make sure you check extraneous roots. So that's it for today in review A. I'll do a review B later on in the week. I hope everybody's doing well, and good luck on the final.